Welcome back to lunch, everyone. Hopefully I didn't sleep. That farmers market's a good example of local foods and sustainability, and it's a great field trip for you guys and girls.
Delicious field trip.
Yes, it's great that stuff like that's going up all over the place. Anyhow, my talk today is energy conservation, our greatest natural resource. It'll be quite different, I think, from the previous talk, but hopefully it's interesting. It's kind of targeted at people who are technically oriented, so hopefully you'll be able to grasp it. I'm sure you will. My background is I'm a physicist. I did work on a master's degree in ESC, Electrical Computer Systems Engineering at the FBI. Took that and went to the incubator center. We started a company. I'll explain a little bit about that in this talk. And grew the company into about a $6 million company today. And moved to the company. I'll get into that. Anyhow, I'm vice president of a local high technology company. So, this talk is about energy conservation. I want to talk a little bit about the opportunities available in conserving energy. Give an example to get us in the mood for how we can save money, save energy, and present a case for conservation, talk about consumption, waste, and what we can do about it. This talk was developed for the purpose of a local website. Our energy independent community, www.oeic.us. It's a really good local resource for sustainability, renewable energy, and anything related to it. The talk grew out of my interest in energy conservation, with my physics background, you'll see it led to a lot of research into how we consume, use, and waste most of our energy. This talk is not about politics or policy. This is mostly technology. It's about reducing waste and improving our economy and preparing for the future. I'm delighted that you people are interested in the future, unlike, as the previous presenter said, most of the U.S. doesn't seem to be. So, what I'd like to do is give an example of the opportunity, and I'd like to give transportation as an example of it. This is how we use energy in the U.S. We use, it's fairly evenly distributed between the sectors that the government uses to segregate energy use. Transportation is about 28%, residential is 22%. So about half of what the available energy that we use in this country, we as individuals have direct responsibility for. Okay, so we can directly impact this and we can indirectly impact this. We as individuals have a lot of leverage for how we use and conserve energy. Now, of this 28%, almost all of it, 60% of it is used for gasoline, and that's almost all cars. Some cars are like trucks. Diesel is mostly heavy trucks transportation. It was surprising to me that how little jet fuel is in this equation, but and it's unfortunate that we use so little natural gas. Natural gas is a much cleaner, much more abundant resource, and there's almost none of it for transportation. That 2% is pretty much all fleet vehicles like buses. Much more efficient, much cleaner resource that we don't use. Here's a graph of energy use in different sectors. You see transportation is the largest growth. The industry, after the oil embargo in the 70s, got the clue. They started conserving and using more efficient processes, and it's been fairly flat since then, even though the economy has actually grown since then. Likewise for industrial, or for residential and commercial. Transportation, on the other hand, keeps growing. We woke up in the oil embargo, started buying lighter cars, more efficient cars, and then we fell asleep and started buying giant cars and driving more, and it's grown ever since. But here's a hopeful indication. I actually think that this is peak consumption for transportation. I think we've reached the point where we finally got a clue, and prices are high enough, and maybe we can go a little bit smarter. But I think that this is a trend that we'll see in the future. We're going to start seeing transportation, energy use in transportation dropping off. As an example of how inefficient transportation is, the engine itself, the modern engine is very efficient. We've done a great job over the past century in improving fuel economy in cars, but still, only about 30% of the energy you put in the gas tank actually is used to produce energy, useful energy. 5% of that's used for things like water pumps and alternators. The drivetrains, about 5%. You get about 20% of that gasoline you put into the tank actually delivered to the wheels. That's just a start. Now that you've wasted 80% of the energy, braking resistance, roller resistance, aerodynamic drag, and you've got to move the car. You take all that into account, the mass of the car, you take that all into account, and less than 1% you use the driver. Okay, so if you're paying $4 a gallon for gas, or $3.50 a gallon for gas, only 1% of that goes to move you. And most of us in the U.S. sit in our cars and in traffic jam, individually, and waste that much energy. So there's a huge opportunity in just this one example of what we can say. If we follow the CAFE standards, which Obama has in place now, by the year 2020, I think, it colors out very good in that graph, but we can, if we, here I have right here the graph. If we save, if we reach the 2022 goal of 50 miles per gallon for an average sized car, normal sized car, we will have achieved what the Prius does today. It doesn't seem to me like that's a huge goal. It's everybody's complaining about how difficult this goal is, but the Prius already achieves its fuel efficiency. If we achieve that fuel efficiency, we will save $400 million per day in oil inputs. It's huge. This is a huge opportunity. And like the previous presenter said, we are way behind the rest of the world. This goal that we don't think we can achieve of CAFE standards is being exceeded by everyone else. So we're way behind. So, how efficient do we think a car could be, a vehicle could be? Engineers, what's the answer? What's the maximum miles per gallon that you think that we can achieve?
Seen 300.
300? Any other guesses?
No, higher.
That's cheating. That's electrical vehicles and renewable energy. Yes, cheating is allowed here. Yeah. But with the fuels of today, the actual answer is 12,665 miles per gallon. That's cheating though a little bit because that's hydrogen equivalent. This is a hydrogen fuel cell, okay, in this vehicle. The actual answer using gasoline is 3,587. So, it's much better than 50 or, the 20 something that we're achieving now. And how do we do that? Very efficient engines, very efficient vehicles, very lightweight vehicles. I'm going to harp a little bit on the lightweight aspect. People don't think that we can use lightweight vehicles because they're unsafe. I need to drive a giant monster truck to take my kid to soccer because I have to be safe, right? Well, a Formula One car that weighs, 1,300 pounds, something like that, can smash into a wall at 200 miles an hour and the driver can walk away with a sprained ankle, as opposed to the giant monster truck that can flip over and kill you. So, lightweight vehicles can be safe, extremely efficient and safe. And we're seeing that coming into fruition now. BMW, the Europeans are way ahead of us. The BMW is introducing this year the i3, all-electric vehicle with a carbon fiber frame and greater than 100 mile range. This is the future. This is what cars will be in the future, vehicles will be in the future. Lightweight, highly efficient structures. And I'm convinced that that's going to lead to reduced consumption and greater efficiency. And there's also sustainable composites. So I think the next presenter will be going into this in a little more depth. But in the European Union, there's an end-of-life vehicle which we have nothing like it here in the country. But by 2015, they're required to have 95% of the vehicle being reusable or recoverable. And to that end, they're making composites in vehicles today, and have been for some time, that are made out of natural fibers and natural resins, or and in a much greater extent renewable, like plastic composites. Oh, by the way, this is very informal. Please ask questions as I go through it. Okay, so this is originally a 20-minute presentation. I'm going to throw a whole bunch of more slides in here. Feel free to ask questions as I go through this. Lightweight boats. I don't know if you followed the Oracle race recently, but they're going 50 miles an hour now.
I saw it on the Colbert report recently.
I'm sorry?
The team appeared on the Colbert report.
Oh, really? That's great. That must have been good.
It was.
It was actually a very exciting race, which is what Larry Ellison wanted. But it's so expensive to get into this. There were only 2 entrants, but this is what you're going to see in the future. You know, it's like Formula One yacht racing.
They said it's like 60 miles per hour.
50 is actually 60 knots probably.
Yeah.
But yeah, it's amazing. You couldn't do it without composites. You're going to see more of this in the future with things like wing, air-assisted transport vehicles. It's happening all over the place. It's starting to happen all over the place because it's either the fuel costs are getting higher or people are carrying more of both. I'm hoping it's both. But if you want to have a human-powered flight, you better use composites. You need lightweight, very efficient structures. If you want a solar-powered airplane, you better use composites. And actually, RPI built a solar plane back in the 70s, solar glider. It was, I think, 110 pounds, and then they painted it, added another 10 or 15 pounds to it. The performance of these materials are amazing. And of course, Bert Rutan flew around the world without refueling as a result of composites. I'm not going to harp on this too much. I just want to bring up the point that this is one way that we can conserve energy. Historically, aircraft has gotten more efficient, has become more efficient. This is passenger per passenger mile, fuel consumption per passenger mile, and it's been steadily decreasing as engines have gotten more efficient and as and their airplanes have gotten lighter. And the main reason why they're getting lighter today is because of composites in aircraft. The composites represent about 50% of the volume of an aircraft now. I'm sorry, 50% by weight, 80% by volume. So the 787 was the first commercial airliner to use composites, and it's 20% more fuel efficient than its predecessors. You can't make a commercial airplane in the future without using composites because it's just not economical anymore because of fuel consumption. So, the reason why I bring this up is because when I was an RPI student here, I was sitting over at JEC, and I was listening to a presentation from NASA on how they were going to make products on the moon, on moon missions. And I was trying to think, well, how would you have a machine shop or something on the moon? And it came up with the idea of additive manufacturing. I'm sure you all know what additive manufacturing is, okay? And now it's a like $5 billion industry. So my dream, sitting over there at JBC, was I want to be able to sit at my computer, design a super cool high-performance structure, which were really hard to make back then. It was all manual labor. This is in 1984. And push a button, print the structure, and then fly away. That was my dream. That dream has been realized now in additive manufacturing, as you're fully aware. But that wasn't good enough. I wanted high-performance structures, not just plastic or metal structures. So I helped start a company. We went through the incubator program. We went to the tech park, and then we grew the tech park and moved to factory in Schenectady, and now that's what we do. We make robots to make high-performance composite structures, and we also use those robots to make the structures in our facility in Schenectady. This is an example of what I call high-performance additive manufacturing, but what the rest of the world calls automated by replacement, AFP. So basically what it's doing is it's taking these spools of material here, which are carbon composite, and it's laying them down using a robot, a strip at a time to build up a structure. And then this structure ends up being a tail boom for a high-performance helicopter. So that was my dream, and it's being realized today. So you can realize your dreams also. All right, so now I'd like to go into a more broad, that was an example. I'd like to go into a broader view of why we should be concerned, why I think we should be concerned. We like energy. Energy is good. We're used to a world where we can jump in our car and drive across the country and use computers, and energy is good, and it's correlated with the economy. That doesn't mean we need to waste as much as we do now. And energy has a cost. We talked about global warming in the previous lecture. I'll go into some of those things in this presentation. But things like pollution, quality of life, national security, energy security. More energy does not necessarily mean better. So we currently export about $1 billion a day in oil. And what does your money buy? The sheikhs of the Middle East have things like gold cars and fleets of gold cars. And this is a private 380 jet that holds 600 people or one sheikh. If you want, wouldn't you like to have $500 million or more to buy your personal airplane? And think of how inefficient that is. Oil to burn and money to burn. We all remember the Gulf oil spill, how awful it was, the loss of life. It's actually the 5th on the list. It was as bad as that was. It was the 5th on the list, and you're probably too young to remember the Exxon Valdez, which everybody recognizes as a horrible natural disaster. Yeah, and that's 22 on the list. It hardly even shows in today's oil spill, in today's major oil spills. On the other hand, we have oil spills all over the place. There was a tanker truck that spilled 9,000 gallons in the Hoosic River just a couple months ago. And these, people don't even think about it anymore because it's so prevalent. Okay? Oil is spilling all over the place. Anytime you see one of these Newton's interference patterns on the ground, that's oil and gasoline spill. For example, there's reportedly 380 million gallons of petroleum spilled every year in the U.S. alone, and 76 million of that ends up in the water. There's been over 150 million leaking underground tanks. We are used to this level of pollution. It doesn't even register with us how our current state of affairs has gotten us into this situation where there's massive pollution and we don't even recognize it. We recognize big things like the oil spill, but the previous presentation talked about nuclear energy, the Fukushima disaster. Well, does anybody remember 3 Mile Island or Chernobyl? All energy has its cost. Coal's hidden costs, massive CO2 pollution, strip mining, acid rain. This is an example of a ash pit that collapsed from a coal-fired power plant and drowned the whole area in ash. It's actually extremely toxic. This ash has a lot of heavy metals and radioactive hazard.
Is that the one from Tennessee?
Yes, it is. That's the one from Tennessee, exactly. And here's an article explaining how that, from Scientific American, showing how fossil fuels actually produce more radiation than nuclear power plants do. It's just distributed all over through the air and in the ash, so it's not, we don't recognize it that much. But it lands on our crops. It's not good, and that's just the radiation. There's heavy metals in the ash that lands on our crops. It's there's a huge cost to coal, and some people anyhow are beginning to recognize that. Natural gas has been recognized as an abundant resource in the U.S., but there have been concerns over potential oil or potential water contamination, explosion hazards, methane contamination of water. Methane is non-toxic, but the fracking fluids aren't. So if we're going to...
What exactly is that picture in the top right?
This right? This here?
Water on fire.
Yeah, that's supposedly a picture of methane pollution in a water well. Okay. One of the reported problems with fracking is that it has a potential to get fracking fluids and methane into the local water. And there have actually been two verified, there's one certain verified case of that in Pennsylvania. And there's been one actual certified case of groundwater pollution from fracking fluids. There's a lot of alarm today about fracking in this area because there's a lot of shale gas under our feet, and people are afraid that the water is going to be contaminated. It certainly could be if it's not extracted properly.
And they haven't been extracted properly, right?
Well,
the wells are leaking. And they're just worried about that.
There's a lot of controversy about this. The actual factual evidence shows that there was one methane contamination in I can't remember, it's out in western Pennsylvania, and that's bad, but methane is not actually toxic. And there was one leaking well that leaked into the groundwater in Wyoming. So there's a potential for leakage. If we're going to take advantage of this abundant, relatively clean resource under our feet, we have to have regulation to make sure that it's done properly. And the fracking fluids, if they are toxic, which are non-toxic fracking fluids today, but if they're going to use toxic ones, they have to make sure that it doesn't contaminate. Okay, so it would seem to me like a really smart thing to do in New York State is to insist that we don't use toxic fracking fluids. They use vegetable oil. I don't really mind that much if vegetable oil gets in my water. I wouldn't like it, but I wouldn't like methane in my water either. But it's not toxic. So the real controversy is, in my mind, anyhow, that there's a potential for leakage, and there's toxic. They're currently using toxic chemicals like toluene and in the fracking fluid. In most fracking fluids, to counteract this, they've come up with non-toxic fracking fluids. We should use those.
But doesn't gas still get into the leaks also?
I'm sorry?
Doesn't the natural gas itself also leak sometimes?
Yes, that's methane. Natural gas is methane.
Right, so you can't really not use that in the process.
Yes. Oh, okay. So besides methane leaking into your water, as is trying to illustrate here, rather dramatically, there's also methane leakage, yes. So at the well, methane is a greenhouse gas. It's a very powerful greenhouse gas. So part of the drilling equation has to be not allowing or minimizing emissions of natural gas. As we use more and more natural gas in our economy, which we will, we have to take great pains to prevent leakage also. Currently, guess what the worst natural gas polluter in the U.S. is?
Cows.
Yes, right. So farming is by far the largest source of natural gas, of methane pollution in the U.S. I don't really want to stop farming, but we could limit the release of methane from natural gas wells. Another thing for this group might understand about natural gas. Natural gas is cleaner than any other fossil fuel, and it's abundant and it's all great for us, except for one thing. It prevents the ultimate solution. It delays the ultimate solution. Having another source of cheap fuel just delays what we really need to get to, which is renewable and sustainable energy. So I would like to hope that natural gas is used more because it's cleaner and will help the environment, but we can't just fall back and assume like we did in the 70s with the oil embargo and keep wasting energy. Wind energy is renewable, sustainable, but no one seems to want it in their backyard. I grew up in western New York, and you wouldn't believe how difficult it was to get wind turbines put in. The farmers all loved it. The farmers wanted it because they make money from it. They can keep their farm going with the money that they get from the windmills, but the people who drive out from the city every day didn't want to look at it. I don't think they look bad myself, but
Bananas. They'll absolutely nothing anywhere near it.
yes, right, exactly, yes. So there's going to be offshore wind farms, and if you've ever been to Germany, it's amazing. Or most of Europe, they're all over the place. And why shouldn't they be in my mind? So anyhow, one of my favorite costs of energy is we love our cars and we accept 100 deaths every day on our highways. The good news is because of modern safety standards, we've fallen from almost 45,000 deaths a year. Actually, I think it was higher than this.
Why is there a peak in 2005 of that?
What's that?
It goes up and then down.
Yeah, there was, I believe this is because of the airbags and improved safety standards. And drunk driving, we're finally taking notice of all of the deaths due to our cars. We love our cars, but we seem to willingly accept this, which just boggles my mind. I mean, I'm sure everybody in the room knows someone who died in a car accident, and it's tragic, and we accept it. We also accept sitting in traffic jams all the time. If you've ever been in LA or West and Northway at rush hour, we just sit in traffic, and it seems to be a way of life. It's bizarre to me. We all moved out of the city, moved to the suburbs, and now we seem to like sitting in traffic jams, wasting energy. I don't understand it. So that's my whole bit about waste and cost of energy. I want to talk now a little more technically about our consumption patterns. Most of the world, I'm going to talk about the world consumption patterns and then U.S. consumption patterns, how we fit into that. Most of the energy in the world is in liquids, petroleum. Coal is rising. That's mostly because of China. And natural gas is showing declining here, but that will be rising. And petroleum will be decreasing just from economics alone. And that will help with CO2 emissions somewhat, especially if it displaces coal, which it's already doing in this country. But the good news is that renewables are increasing. Nuclear is going to be dropping because of the costs associated with it. Here's a look at world energy consumption. There's somewhat good news here. In the most wealthiest countries, the OECD countries, we're already seeing a decline in energy usage because of efficiencies, and maybe we're saturated. I doubt that we're saturated, but we're actually beginning to cut fuel usage in the richer countries. However, in the non-OECD countries, people who have rising economy, fuel consumption is growing drastically. And this is a projection to 2040. This has bad implications for climate if we don't do something about fossil fuel consumption, something more. Here's a map of world energy consumption per capita. And you'll see that we are one of the highest consumers of energy. Canada's a little bit higher. I'll get into the reason why Canada's a little bit higher, is higher than we are. But we consume a lot of energy per person compared to the rest of the world. We consume about 25% of the world's economy with only 5% of the population. So there's a lot of room for improvement in the U.S. And our GDP is high, okay? There is a correlation between energy usage and GDP, but by any measure, we're high in energy consumption. And here's a graph of energy consumption of the U.S. versus the world. This is the former Soviet Union. And you can see that we historically have used about twice as much as similar economies in Europe. You'll notice that there was a decrease in the 70s. That's what higher prices and knowledge and concern about energy usage can do. And China's increasing, of course. Quality of life is not necessarily equal to energy consumption. If we ignore Iceland, which consumes a huge amount of energy, the U.S. is way above our counterparts in other countries with similar economies.
Doesn't Iceland produce all of its power by renewables?
Yes, they do. That doesn't. I don't believe that this graph actually takes it into consideration. This is total energy use, and they do use a lot of geothermal energy in Iceland.
What's HDI?
It's the United Nations Human Development Index. It's a measure of the well-being of the citizens of the country. So we're up here with most of the rest of the industrialized nations, but we're a much larger energy consumer than others with our same HDI rating. So we have a problem. What we do about it? I'm not very good at politics, but Reagan said that we're conservative. He's a conservative, so what do we do? We're conservative. That's a great thing. I wish all conservatives thought that way. Former President Bush said we're addicted to oil. That's a strange thing for an oil man to say, but it's honest anyhow. And Obama, when he came into office, said that he was going to end independence on imported oil in 10 years. We haven't done much about it, but we're heading that direction. It's mostly because of natural gas rather than pellets and gas.
The goal specifically is just from the Middle East, because we only import 10% of our fossil fuels from the Middle East.
It's more than 10%, but yes, it's right. The goal is
Achievable goal.
Yeah, I mean, we could produce all of our fossil fuels if we if we wanted to, but maybe 40% because it's cheaper to import.
Not quite. We import as much as we do. I probably have a graph in here somewhere that shows that, but we import as much as we do because we didn't have enough production. We could not produce enough. That was before we discovered natural gas, extraction of natural gas and improved methods of production of oil. Imports are dropping now rather radically, and it's because of the improved production methods, and especially natural gas. But yes, we import something like 10 or 20% or so from the Middle East, and a lot from Canada.
A lot from Mexico too.
Mexico, Venezuela. I have a graphic here. I'll show it later, probably. But yeah, so it's all imported oil. The general idea is to keep our energy security, to keep the source domestic. There's a lot of talk about this. We brought up in the last presentation the oil pipeline that's being proposed. What was it? Keystone, right? Yes. That is the previous presenter presented it as a bad idea from a philosophical point. It's just a bad idea. I mean, our use of petroleum products is dropping drastically. You don't have to be philosophical about it. By the time they get the pipeline built, we won't be using petroleum anymore, and the tar sands will be, will not be a good idea. I sold all my stock in the tar sands because it's a dead deal. It's going to be a dead deal. It's expensive to extract, by any measure, the tar sands oil. And the idea of building a pipeline across the U.S. so that we can bring it to Houston and export it is just a bad idea.
So you're not ready to use it.
I'm sorry?
It's going to go to Texas and then be imported around the world, right?
Definitely, because it's a world market. But we presumably could benefit somewhat from that. But
If we wanted to use it in the States, we wouldn't bring it to Texas. If we wanted to use it in the States, we wouldn't be bringing it to Texas.
Right.
All the way across the country.
Well, it's a big pipeline. You could just have.
You could have branches, yeah, I guess.
well, no, it has to go to Houston because that's where it has to go to the Gulf Coast because that's where all the refining is done.
Oh, okay.
Okay,
Because that's where it is.
and oh, by the way, all of our refineries are maxed out right now. So you have to, you either have to reduce consumption, or you have to either build more plants or reduce consumption.
Sounds like a huge investment of the infrastructure for the declining market.
It's a huge investment in the infrastructure and by the time it's built, it'll be obsolete. That's my opinion, because it's much more economical to frack a well in Pennsylvania than it is to use an expensive extraction process. They dig it out of the ground and spend about 25% of the energy that's extracted to take it out of the sand, and then clean it up. I've actually been there. It's Fort McMurray in northern Alberta, and there's like structures like the pyramids, these yellow structures like the pyramids. It's unbelievable. They take the sulfur out of the petroleum and then cast it into these giant, 100-ton bricks and stack them up. There's like pyramids all over the place. It's amazing. But we need to transition away from wasteful resources like that. So now we're going to talk a little bit about waste. This is a rather busy chart, which is full of information. You're probably one of the few audiences who can actually grasp this. But over here we have the sources: solar, nuclear, hydro, wind, geothermal, natural gas, coal, by quads. A stupid unit. Right? What is a quadrillion? I think it's 10 to the 15 BTU, right? Luckily, a quad is about the same as an exajoule. Okay? That kind of makes sense. So think of this as exajoules. Okay? So coal is used almost exclusively for electrical generation, and a little bit is used for industrial. Petroleum is almost all used for transportation, as I said in the previous discussion. This graph shows about 25%, thereabouts, of energy wasted, and from the previous discussion, you know that this is extremely optimistic. This is basically just what's wasted before it gets to the wheels, okay? So all of this is very optimistic. If you take the most optimistic viewpoint you can about energy usage and energy waste, we start at a waste of over 50%. Almost half of the energy we use for why we use energy for the benefits of energy is wasted right off the bat. And then over here, as I started to talk about in the transportation discussion, we waste most of that also. The opportunity to conserve this wasted energy is huge, and it's something that we need to we need to deal with more in the future. As an example I gave before, less than 1% of fuel is used for transportation to actually move us around, which I think is the goal of transportation, and about 2% of electrical energy that's used, say coal for example, is actually used to produce light, usable light. So any savings we do over here has a huge benefit over here. So we waste a lot of energy, and what can we do about it? And unlike the previous presenter who painted this picture of evil CO2 polluting companies, we're to blame. My opinion is we're to blame. They wouldn't be producing the pollution if we didn't want it. Producing the energy if we didn't want it. If we insist on less pollution, we might get it. And that's why I want to commend this crowd for doing what we need is a lot more people like you to send the message out there that we want a cleaner world, more sustainable. We can't do that with our current thought process. We need to, as Einstein said, you can't solve the problems with the same thing we used to create them. We need to change our thinking about how we use and waste energy to build a more sustainable world. So this is the same thing I said before. Roughly a quarter from each of these sectors. Roughly a quarter of the energy is in each of these sectors. Let's look a little bit into each one of these sectors. We already talked about transportation. So besides the fact that our vehicles are extremely inefficient and we can do a lot to improve their efficiency through lightweight materials and more efficient engines and such, we could also have more than one person in the car. An easy way to get twice the gas mileage is to have more than one person in the car. Just common sense things, you know. Motorcycles use lower weight vehicles. Commuter rail in the U.S. is an average of 39 miles per gallon. Compare that to in Europe, the high-speed commuter trains in Europe with a typical 85% capacity occupancy rate is 920 miles per hour. The train system in Europe is massively efficient compared to our system, Sydney traffic jams.
And it's used. If it's 85% occupancy, it's used a lot too.
Yes, it's used a lot, right, yes. If you've ever been to Europe or any other place in the world, I mean, the train systems work and they're efficient, and I don't understand why we don't do it more. There's been a proposal to create a commuter train from Clifton Park to here. Every day, people sit in a traffic jam all day long, for hours, both ways, going back and forth from Clifton Park to Albany. It's a no-brainer, but it's going nowhere. I don't understand. Yes.
The European rail system is really technologically advanced and quick and efficient, but because of all those things, it's really expensive. So it's not actually like the mode of transit for less like economically off people. It's cheaper for them to buy a car because they're manufactured. Well, for Germany, for instance, the trains are so expensive that they're like the large like cross country trains. It's cheaper to buy a car manufactured in Germany that's small, lightweight, and rather efficient than to get a train pass because it's like 80 euros for a 3-hour train ride.
That's surprising to me.
Yeah.
I mean, I don't know if I actually believe that because I've ridden the trains frequently in Europe and you know, there's lots of tolls and gas prices are, you know, diesel, most cars are diesel in Europe and the price is what, 15?
They subsidize the trains and they tax gas.
Yeah.
Oh, they subsidize them?
Yeah.
Oh, okay.
I mean, I don't know what the price is now, but it's something like 12 euros.
I rode the train around Germany this summer a bunch, and I mean, if you're going like across the country, it is expensive. I think it's a lot cheaper if you actually buy in advance and planning in advance.
Yeah.
Yeah.
And I mean, I don't know how expensive cars are there, but I'm pretty sure most of the EU taxes gas heavily. So it's very expensive to drive.
Yeah, I may be less informed than I hope, but it's not as clear cut as efficient trains proceed forward.
Well, and also
less-
super fast trains, you lose the energy efficiency that some of them do.
Yeah, it never is simple. It's, you know, I'm a scientist, it seems simple to me, but people love their cars. You know, it's amazing. I know a guy in the Netherlands who bought a car, a little tiny Fiat. And the thing is, you know, so it's like the Fiats they sell here now. You know, they're tiny by U.S. standards. And he paid 50% sales tax, another 80% luxury tax. I mean, the thing cost him like 15 grand. It's unbelievable. You know? Not 50 grand, it was like 50 grand. You know, $1,000.
But they also use like cargo bikes for their families, so it goes both ways.
We love our cars, but there's a downside to it also. That people in other countries understand better than us. So air transportation, you know, average is stated here is 35 miles per gallon per passenger mile. 35 miles.
I feel like that number has to go up some stress.
It has gone up. It has. Like a 747 is with full occupancy, which is 91 miles per gallon. Yeah, so, and 787s are more efficient also. So these are kind of old figures. Railroads are much more efficient than heavy trucks. About 10 times more if you ship by rail. Heavy trucks are getting more efficient also. Walmart has a goal of doubling their fuel efficiency for their fleet. The fuel use, not necessarily efficiency. They have a goal of doubling the fuel.
Having fuel use? Hopefully they don't want to double fuel use.
No, half the fuel use. Cut the fuel use by half by between 2005 and 2015, and they're almost there now. So they're going to actually reach that goal by more efficient trucks and better use of the delivery schedule.
FedEx is able to save money because they schedule more right turns into their route. They try and maximize right turns because you can go right on red as opposed to having to idle
They
for a
tested
run.
that on the clusters.
Yeah, what was the result?
I think it was confirmed, actually.
It's all of that. There's a lot of IT in this. You know, I visited the Hanford warehouse locally, and it's astounding. I mean, it's all computerized. They drive around and pick the orders on the lift trucks. They have a computer screen on the lift truck which tells them what to pick, and it picks it in the order of where it's going to be delivered and where it's going to be stacked in the warehouse. And you know, there's a lot of efficiency just from optimized route scheduling and stuff like that. So, residential energy use. This is showing roughly how energy is used in our homes. 25% roughly of lighting, a lot of space heating, and there's plenty of opportunities for savings here. Most residential heating, energy use actually is natural gas, and that's growing steadily. Good news, much like energy usage in general, is that the trend for the ever-increasing energy use in homes is starting to decrease. I hope the era of the McMansion is over with, just like the era of the SUV. We finally realized that we don't need to live in a 5-bedroom mansion, and as a result, the residential consumption is going down. This is just a graph of showing energy consumption residentially by per region. It's a little surprising that the Northeast is lower than the Midwest and the South. Yes, yes. Lighting has been decreasing. That's a good news story. I think I have something in here about lighting. Anyhow, we'll get to that. Just by using Energy Star appliances, you can get a 40% savings in energy with a refrigerator and 50% with a dryer. Actually, I think it's a washer. So, buying energy efficient appliances can save massive amounts of energy. Here's the lighting one. Okay, so fluorescent bulbs as compared to incandescent bulbs are about 4 times more efficient, and LED lighting is about 10 times more efficient than incandescent. And you're seeing LEDs all over the place now because of this. And trucks have LED lighting exactly for this reason and for the fact that they last longer, but it saves energy. It won't be too long and headlights will be LEDs. All the accessory lights are now becoming LEDs, but there's huge energy savings available. We've already discussed the huge amount of waste that goes into producing energy for light. And in industry, anybody notice what is the largest consumer of energy in industry?
Energy.
Energy. Imagine that. So saving energy in end use has a huge impact on generation, which also causes secondary effects in reducing energy in production. And if we go back, if you think back to the graph that showed the world energy consumption, the energy producers are also the world's largest energy users. And this is a large factor in that. It takes a lot of energy to produce energy, especially if you're extracting it from tar sands. And that's why Canada was the highest.
The factored in average hour.
I'm sorry?
The input of energy and output is not cost effective enough.
Well, it's cost effective if there's no other alternative.
We're still quite positive on the ROI as a society. The energy return on investment is still very high.
It's very low.
It's still 10 to 20.
But it is ironic that they spend a lot of energy, a lot of money looking for more.
Right, well, we spend an increasing amount looking
Yeah.
for more, so discoveries and stuff, but in terms of energy consumption
Yeah,
to get stuff out, we're still
it's
quite positive.
Wow, I just realized I'm almost on time here. Amazing. All right, so the biggest waste of energy, surprise, is waste heat. Things like cogeneration can reuse this energy instead of just producing electricity or industrial process energy and then throwing the heat away. Use the heat for other processes like heating the plant. That's or combined cycle energy. There's a lot of opportunity. There's so much wasted energy in the form of heat, low quality energy. There's a huge opportunity there. And there's companies actually started, there's one locally to generate electricity from waste heat. Commercial energy is like shopping malls, restaurants, hotels. Most of the energies there is used in space heating, lighting is going to continue to drop. So that's a good news story for this sector. Is as more efficient lighting gets used, there'll be large gains in there. And there's a thing called district heating, which is exactly what I just said. You use the energy to produce things like electricity or whatever, and then you use the waste heat to heat a whole block of businesses instead of just one business, and then throw the rest of the smokestack. So, I believe we've actually reached the tipping point. This is a slide from a couple years ago. I think that all of these factors have finally made an impact, and we finally reached the tipping point, and we're going to see, at least in this country, a decline in energy consumption. And there's a whole lot more room to improve. This is what I already said. I think we've reached that point. And the good news is renewables are on the rise. And if you want to look into this further, the thing that led me to this presentation in the first place is our Energy Independent Community website, which has great resources on all kinds of different energy issues. NYSERDA is a New York State Energy Research Development Agency. They have a great website and are committed to energy conservation. And of course, the DOE also has some good resources. So in summary, our energy consumption, at least in the world, is increasing. In the U.S., it's starting to decrease. That's good news. The cost of energy is high, and it's going to continue to rise. There is plenty of opportunities to conserve energy, and so energy conservation is our greatest natural resource. Any questions?